Hey guys, this video is for educational purposes only. Please do not break the law. Okay, welcome back to another episode of the Growers MBA podcast. I'm here with Mr. Elliott Gorfain, our head CEA consultant over at greenthumbdepot.com. Very excited for this episode. Last week, or actually, just to give you guys a little bit of background, we started off the first episode talking about the most optimal grow setup for people that are looking to go from being a home grower into a commercial grow. And then last week, we talked about rolling benches and how that can actually save you, not just save you space, but just optimize the entire space. I mean, when it comes to optimizing your grow, you want to make sure you're making use of every inch that you have there, right? So this week, without further ado, we're actually talking about one of the more complicated subjects. And I'm excited for this one because there's a lot to take in when you are broaching the very technical subject of dehumidifiers. And, one of the things that we're constantly seeing, people are constantly calling us, getting dehumidifier quotes. They're either completely undersized or completely oversized. And a lot of times they just haven't really done the math right. There's some very simple ways to do the math that don't take into account like a lot of the other stuff you really should be taking into account. And that's what I want to cover today. So, I'll stop talking here and I'm going to ask you, Elliott, just let's start this big conversation off. First question. So we get customers who are calling and they want to know how many dehumidifiers do I need? How much pints do I need? And the topic is quite complicated. And so, Elliott, what are the first things that you're going to ask a customer that calls you that's trying to figure out how to size their room?
Absolutely. Yeah. Actually, before we get into that, I'd just like to take just a brief moment to kind of explain to folks who don't already know why dehumidification is so important. So essentially, when you're doing, controlled environmental agriculture, every day you're putting hundreds of gallons, if not more, into a room through the irrigation supply. And all of that water has to go somewhere. And the plants will transpire the vast majority of that water, evapotranspiration. So essentially they exhale about 97% of that moisture that they absorb through the roots. So if you're putting in 300 gallons of water, you're going to have to pull out 300 gallons of water from the air every day. And if you cannot do that, very quickly, things will go bad. And everything that you're doing, it doesn't matter how good you have everything else worked out. Lack of proper dehumidification will kill any grow in a heartbeat. So definitely want to take care of that and properly size the dehus. But there's a basic concept I want to explain. And so there's this thing called vapor pressure deficit. And that's kind of a fancy technical term. And it's used to describe the amount of moisture that the air can hold. So this is dependent upon temperature. So really warm air can hold much higher levels of moisture, much more water, and very cold air is going to hold very little moisture. And this is actually why in nature we have rain, right? So you have a warm front laden with moisture, it hits a cold front, the warm front cools down, it can't hold as much moisture as it has anymore, so it precipitates out in the form of rain. And that's essentially kind of at its core what a dehumidifier does. It cools the warm, moist air, the moisture falls out. Instead of raining, it precipitates out on the evaporator coil, which is kind of interesting because the water condenses on the evaporator coil, but that's another story. But so it's very important. This concept of vapor pressure deficit is really the difference between what the air can hold, the amount of moisture the air can hold at a given time, at a given temperature rather, versus how much moisture is in that air. And you always want to have some vapor pressure deficit because the way that plants work, you could kind of conceptualize it as a straw, and you need that moisture to be sucked up through the roots, up through the plant, and evaporated out through the leaves. And if you don't have a vapor pressure deficit, if the air cannot accept any more moisture, then that whole process completely stops. So you want the air to be dry enough, if you will, that it can aid in removing the moisture from the plants. So it's extremely important. If you ever get to zero VPD or essentially 100% relative humidity, you're going to have a lot of problems. The plants are going to die. You're going to get powdery mildew. You're going to get botrytis, mold, all sorts of things. So it's important to maintain that. And therefore, dehumidification is one of the most important things that you can do. And unfortunately, a lot of people, there's a lot of like rules of thumbs out there where you can kind of estimate how much dehumidification you need, but most of those are not really good enough. You really want to do a little bit deeper dive to get proper sizing.
Elliot, you mentioned that there's some like kind of go-to calculations for how people are measuring, how they can find out what pints per day they need. Could you tell me a little bit more like what is wrong with that calculation that's kind of going around and which is the better way to approach it?
Yeah, absolutely. There's a lot of different methods that people use. One of them is, they're estimating it based on square footage. They're estimating it based on the plant count and how big the plants are. Unfortunately, none of these things really matter. What really matters is how much water through irrigation are you putting into that room every day? Because the plants will evapotranspirate approximately 97% of that water. That's really the main figure that you need to know is how much irrigation is going in, because almost all of that water needs to come back out.
Okay, so you just said almost. So what values actually reduce that?
Yeah, so a certain amount of the water, if you're doing typical commercial setup, you're doing drain to waste. So you're irrigating the plants top down, drain to waste, and you always want to over irrigate so that the irrigation volume that you're applying will actually drip out of the plant and you have an excess. And you typically want to do about 10, maybe 15% excess so that you can flush some of the accumulated salts and waste products of the plant out of the pot or out of the cube, and that goes directly to waste. So if you're irrigating with, let's say, 1,000 gallons a day and you're doing 10% drain to waste, then 100 gallons of that irrigation is going to go directly down the drain and out. And you don't have to pull that out of the air because it's removed through the plumbing.
And are there any other things that reduce that load?
Yeah, so the plants themselves will incorporate a small portion of that water into the sugars when they're doing photosynthesis and other molecules. So that can vary, but it's different in the daytime and the nighttime. It's different based on the growth cycle of the plant, the size of the plant. But in general, we estimate somewhere between 95 and 99% is evapotranspirated. So you can deduct, we use a figure here of 97%. So we can deduct another 3% from that irrigation input. So now you're taking off typically 10% for drain to waste, 3% for the plant metabolism. And then the next one would be your HVAC system. So your air conditioning system will actually remove some moisture as well. But I don't like to use that I don't like to input that into our calculations unless people are very confident of how much moisture their air conditioning system can remove, because it varies a lot. It depends on the efficiency of the air conditioning equipment. Actually, more efficient air conditioning will remove less moisture because it's more optimized to cool, and less efficient air conditioners will actually function a bit more like a dehumidifier. So because of these variables, I tend to leave that out unless a customer requests it and they know the exact value of their air conditioning system and how much that can remove.
So, and to add on to that, are there any things that actually increase the amount of dehumidification that would be needed?
Absolutely. What we're talking about here is in a sealed room. And we all know that even though the rooms are intentionally sealed, there can be infiltration of outside air if it's not completely and properly sealed. That outside air is going to carry some amount of moisture in with it. So you really want to make sure your rooms are sealed, not just for the air conditioning and, potentially, hopefully, CO2 augmentation, but also to keep that humidity out. But regardless, every time you open that door, because you have to go into the grow room every day and tend to your ladies, right? So every time you open that door, you are allowing some moisture to ingress along, when the humans pass through. Ourselves, as humans, we respirate, and when we exhale, like the plants, we also exhale moisture. These factors are minimal when compared to the fertigation and the irrigation that we apply. So we generally exclude them. If it's a decent sealed room, we can kind of ignore those. And what we do is we roll everything, all of those little factors, we roll it into just saying we need some extra capacity just in general to accommodate for those things. And in fact, one of the other things that we need that extra capacity for is because, and this is very important, the dehumidifiers are not always like the amount that they need to remove changes throughout the day. When the lights are on, right after the lights turn off, before the lights turn on in the morning, there are different needs. And so just saying pints per day isn't good enough, because when those lights turn off, they need to be able to pull out a lot really quickly. So if you sized it perfectly evenly throughout the day, it's going to take them way too long to get that moisture out of the air when the lights turn off.
Okay, so Elliot, why is there such a demand for increased dehumidification when the lights are turned off?
Yeah, so there's a few reasons actually. So first of all, when the lights turn off, the temperature of the room drops dramatically. So the the air conditioning units will turn off at some point. The air conditioning units are providing some dehumidification, so you're losing that dehumidification. In addition, the temperature, and this is the main thing, the temperature of the room is going to drop, right? So, and that, because that's why the air conditioner turns on. That's why the air conditioner turns off, because the lights aren't generating heat. So the ACs don't need to run. The rooms get a lot colder at night. And as I was alluding to earlier, when I said, remember, warm air holds a lot of moisture, cold air does not. So as the room cools off, you will have the same amount of moisture in the air as far as like grams of water, but the air cannot hold that moisture. And so then that's why you need to get that moisture out as soon as possible before it drops below the dew point. And which means basically, if you drop below the dew point, it's gonna rain. There's gonna be moisture accumulating on all the surfaces. So it's very important to get that moisture out really quickly when the lights are off.
So Elliot, so how much extra capacity do we typically kind of calculate when we're trying to calculate the extra capacity needed when the lights go off?
Yeah, the standard in the industry is 25 to 30%, and that works well.
Are there any other ways that we can mitigate the increase in demand when the lights go off?
Absolutely. One of them is to do what we call sunsetting the lights. So instead of just taking it from, full blast at 100% light output and then going to zero, we can use our light controllers to gradually dim the lights over maybe the last half hour, kind of simulating, natural daylight and how the sun works. By doing that, you're allowing the conditions in the room to gradually accommodate these changes. The humidity, the temperature, they'll all start changing slowly, and that gives time for the dehumidifiers to actually catch up. And the other thing that you can do is you can program your dehumidifiers to begin removing more moisture. So you can take the set points and you can set them such that they actually are trying to dry out the air more than you really want as you approach lights off, so that is when the lights do go off, you're starting from a drier baseline and there's less moisture in the air. So as it cools, there's less moisture to potentially precipitate out.
So we've taken into account the gallons of irrigation that's going to be going in. We've reduced by a certain amount to cover the drain to waste and the transpiration. And then we've also added back in the extra capacity for lights off. So quite a few things that we're taking into account here. Is there any extra steps after that?
Absolutely. So one of the most important steps, and this is very important to realize, is that dehumidifiers do not operate at the same capacity with different environmental conditions. So as the air becomes colder and drier, they become less and less efficient at removing moisture. So when you look at a dehumidifier, let's say you're looking at a Quest 746, right? So that unit is spec'd at 746 pints per day at 80 degrees Fahrenheit and 60% relative humidity. When you drop that temperature and that humidity, it's going to function much less efficiently. So hopefully there's not too many folks out there that are flowering at 80 degrees and 60% relative humidity. That's not really ideal for flowering. It's certainly not the end of flowering, maybe the beginning. That's more like a vegetative environmental conditions. That's pretty close, depending if you're using CO2 or not. Now, some units like Quest will provide figures for lower temps and lower humidity as well, like 75 and 50, 75 Fahrenheit, 50% relative humidity. Any good dehumidifier manufacturer is going to provide either a calculator or what they call a performance curve, where you can use the humidity and the temperature to calculate out the capacity at that environmental condition. So when you're determining what the capacity is for your units, you always want to use the most extreme conditions that your plants are going to experience throughout the flower cycle. So in general, you're going to start warmer and moisture in flower, and then at the very end, you're going to get colder and you're going to get drier. And you want to size your dehus based on that peak need, which would be the coldest and driest moment, and the peak irrigation when you're irrigating the most. So this is typically, peak irrigation might be, week 6 or 7, and the same with the temperatures. I mean, the temperatures are actually, and relative humidity is going to be the coldest and driest at the very end, right? But take like week 8 temperature and relative humidity, take like week 6 or 7 for peak irrigation. And that's going to be your highest demand that you're going to need, or the most trying conditions for the dehumidification.
All right, so we've covered a lot here. Very technical conversation, as I kind of preluded in the intro. I don't want to completely blow everybody's minds, but is there anything else that someone should know when they're looking to size their dehumidifier? Because I would like to cover as much as we possibly can so that nobody is leaving this episode being like, well, he didn't answer this question. Is there anything else that you think someone should know?
Yeah, actually, there are some important considerations. So one of the really important things is the heat load. So, every piece of machinery in your grow room is going to contribute some heat to the room, and dehus are not exempt from this. So the machine itself, the compressor, the fan, they generate heat. And you can calculate out the heat load that a dehumidifier will contribute to the room by the wattage. And you simply take the watts, you multiply it by 3.412142, and that's going to tell you exactly the amount of BTUs per hour that machinery is going to contribute in the form of heat to the room. You don't have to use all the decimal points, but I like to. And so you definitely need to determine your dehumidification plan before you do your air conditioning plan, because your air conditioning always has to be last, because every other piece of equipment is going to increase that heat load. And so you got to mop it up last with the air conditioner when you add in the heat load from the lights, the dehus, the fans, etc.
Okay, and is there anything else?
Actually, there's three other minor things I would say. The first one being the CFMs on the fan. So a dehumidifier has a compressor, has evaporator coil, condenser coil, and it has a fan. And the fans will blow, fans, typically one, will blow air over the coils. So these are very important. If you have more CFMs, this is cubic feet per minute, the higher the CFMs on the fan, the more air moving over the coils. So in general, the more effective your dehu can be if that fan has a higher CFM. The other one would just be, try to use the highest, well, it depends on your situation, but in general, I always recommend using the highest voltage for your dehus that you can, because that's going to save room on your panel. We talked about this, I think, in the first episode of this series, where anytime that if you can double the voltage, if you go from 240 to 480 with a piece of machinery, your amps will be cut in half. So if you're limited with the number of amps on your panel, you always want to get the highest voltage equipment that you can to save those amps, so you have enough for everything that you need to operate. And then the last one is just don't forget the condensation pumps. The dehumidifiers will drain fluid out that needs to be pumped out of the room, and typically that's done you can do it with gravity, depending on your setup, but a lot of times you also want a condensation pump to help it along. And then also you can mount your dehues. The best way to do this in your room is to hang your dehues with threaded rod. Every dehu that is a commercial unit, it comes ready to be hung with threaded rod from the ceiling, from your unistruts, whatever. Or if you don't have that option, or if regulations insist upon it, you can also use some other hardware to hang your dehu, either as a safety or as a primary method of hanging. It's kind of like, do you want fries with that? You always got to get the fries.
So Elliot, one of the other things I wanted to bring up was, we have a lot of customers who call and they're like, yeah, I want two, let's say Quest 746s, right? Which would be about, 1,500 pints per day or so, right? But what's the difference between that and like 5 Quest 335s, which is like, yeah, I mean, it's maybe a little bit more, but what should someone take into consideration when thinking about, just 2 huge units or multiple smaller units?
Yeah, there's actually 2 really important reasons why you want to use smaller units. You don't want to use just 1 big unit or 2 big units. The first one that's really important is just redundancy. If you have 2 Quest 746s and one of them goes down, now you're at half capacity and you're in a world of hurt. If you have 5s and one goes down, you've only lost 20% of your capacity. So that gives you time to acquire another unit or maybe bring a mobile unit in or something like that. The other thing, which is also equally important, is it allows you to fine tune the capacity to meet the needs of the phase that you're in when you're flowering. So remember, we started out and I said, you want to size your dehues for the maximum load that they will need, which is in maybe week 6, week 7, right? And so in the beginning, week 1, week 2, you don't need all of those dehues. And you want to be able to shut some of them down because you don't want your dehues to be oversized or they're going to be cycling constantly. And so what this allows you to do is cycling, meaning turning on and turning off because they're just maxed out. What you can do in week 1 or 2 is you can shut off most of your dehues and then gradually turn them on through week 3, week 4, week 5, week 6. And if you have them, if you have 4 or 5 small, decent sized units, it gives you more flexibility. And what I like to do is I like to say maybe do 4, 508s and then 1 225 or something like that. And because that gives you an even greater ability to fine tune it. You could shut down a couple of 508s at the very beginning, and then you could turn on the 225 in the next week. And then when you need more the following week, you could shut off the 225, but turn on one of the 508s. So it gives you much more ability to fine tune the capacity to meet the needs at that particular phase.
All right, Elliot. So one of the last things I wanted to mention as well is that I've heard you talk to some of these customers before about staging. And so what is that? Could you tell me a little bit more about that?
Yeah, absolutely. It's a good, important point to discuss. So the heart of the dehu is a compressor, and these are powerful compressors. And whenever they start, they go from 0 to 100. And when they do that, there's a very large inrush current associated with it. And if you have all of your dehues operating off of the same humidistat, that means everyone is going to turn on at the same time. And you definitely don't want that to happen. That's a good way to trip your breakers. So we always recommend using a separate humidistat for each of your dehues so you can stage each one to turn on at slightly different set points. So you might have one turn on at, 60%, one turn on at 59, one turn on at 58, and so forth. And same with, the other end turning off. And that way they don't all turn on at the same time. And having one dehu turn on and have that inrush current is not a problem. But like I said, having many of them turn on at the same time is a problem. So you definitely want to use different humidistats for each of the dehumidifiers and set them to slightly different set points to avoid that complication.
So you mentioned heat load earlier. I do want to ask again because it intrigued me. So you mentioned heat load. Is there any other type of heat load that should be considered besides the mechanical heat load?
Well, Actually, no. In with a CEA system, you really only want to consider the mechanical heat load. But I do want to mention this because it can be confusing to people. Most DHU companies will only mention mechanical heat load because for CEA systems, that's really what we need. But there is a company that also lists heat of condensation, and you don't need that. You don't need to worry about heat of condensation. Just to briefly explain what that is, heat of condensation is when the evaporator coil is cooling the air and the fan is blowing the warm, moist air over that, and the moisture in the air condenses on that evaporator coil, that releases heat. And that is a lot of heat that it releases. But we don't need to worry about it because the amount of heat that it releases is exactly equal to the amount of heat that is absorbed when the moisture evaporates through evapotranspiration out of the plant. So those heat loads actually balance the positive and the negative. So when a plant evapotranspires and the moisture out of its stomata, that creates a cooling effect because the moisture is transitioning from a liquid phase in the plant to a gaseous phase in the air. And the reverse happens at the evaporator coil in the DHU. And the amount of heat generated and absorbed in that process is exactly equal. So you don't need to worry about the heat of condensation. Now, why does this company list the heat of condensation? Because if you're using dehumidifiers in a different application, like to dehumidify a warehouse that's open to the environment, then that heat of evaporation is very important because, or heat of condensation rather, is very important because when you're bringing moist air into the room, you do have to worry about that heat of condensation. When you're bringing liquid water into the room through irrigation, you don't, because it starts as a liquid, the plant evapotranspires the moisture, that cools the air, but then when you dehu it, that heats the air. So it's a net zero. But when you bring warm, moist air into a room, it doesn't start as a liquid. You only get the heat of condensation on that evaporator coil. And that's why you want to close those doors once you get into the grow room. You want to make sure it's sealed because, again, that latent heat, which is the heat that the heat content of the air when it has moisture, or the heat content of the moisture in the air, that is a killer. So you definitely want to keep that infiltration of moist air out of the grow.
I'm trying to wrap my mind around this a little bit. That's like very complicated, and I think maybe one time we might have a beer and sit down and talk about this a little bit deeper. Maybe have a full other episode to really dive into this. But let me just try to understand what I'm hearing here. It sounds to me like you said that the moisture in the air condenses on the evaporator coil, but I would think that it would condense on the condenser coil.
Yeah, it's a little confusing. The very confusing. The dehumidifier, the coils on the dehumidifier are named with respect to the refrigerant inside the coil. So the refrigerant is evaporating at the evaporator coil. But when the refrigerant evaporates, that cools the surrounding environment. And that's why the evaporator coil gets very cold. And that, therefore, on the outside of the coil in the room, when the warm, moist air hits that evaporator coil, that's where the moisture in the air condenses. But the coils are named after the refrigerant. And, we typically are thinking in terms of the room, and that's why they're reversed. So the refrigerant evaporates at the evaporator coil, it recondenses at the condenser coil, and yes, the condenser coil is actually really hot. So that's how that works.
At the risk of losing our audience a little bit here, I'm going to ask you one last final question. If the heat is released when water condenses on the evaporator coil, then why isn't the opposite happening and there's a cooling effect at the condensing coil?
Well, remember, there has to be water involved. So the condensing coil is where the refrigerant is condensing and it's releasing heat. In order for there to be a cooling effect, there would have to be water evaporating on the condensing coil. and there isn't water you would have to submerge the evaporating coil in a standing body of water or something. And we don't want to do that because that would put more moisture back in the air. So it's a dry side of the piece of equipment. And that heat that gets released into the room, though, is important in order to rewarm the air so it can then absorb more moisture. Because if you just release cold air back out of the machine, it can't absorb more moisture. It's essentially kind of like wringing out the sponge so it can go out there and soak up more moisture.
All right, very interesting. Very interesting. Well, I think we've covered a lot today, Elliott. If anybody else still has questions, if there's anything left to be questioned about how to size your grow room, please reach out. Please reach out. You can talk to Elliott direct and you can ask him. I mean, the guy clearly knows a lot. So we'd love to help you guys out with any of your dehumidification needs, grow lights, soil, fertilizers, anything you need, we can help you guys out with. So Elliott, as always, I appreciate your time. That was extremely informative.
Glad to be here, James. And let's do it again next week.
All right. Talk to you soon.
All right.